So what we're going to do with this periodic table, guys, this will be used for the entire year to help you name ionic compounds. All right, we're going to find out that there are three different types of rules for the different types of ions that we have with ionic compounds. Today is all about ionic compounds. We will not be dealing with covalent ones until the beginning or middle of next week. Those are the ones that typically people find easier to name. So we will do the harder ones first and get as much practice as we can with those. So today, guys, we're just going to talk about the three types of ions and kind of learn those rules here today. So first off, type 1. Does not matter what color you guys use. All right, type 1. If you get your packet out from last week, not the practice packet, you'll be getting that today with your vocab terms. But the packet, guys, you got from the test. Get that out and look at model number 1 on there, because that's going to kind of help you identify or start to identify the types. Thanks. Thanks for letting me know. It's all good. I appreciate it. That's why I said thanks for letting me know. No. Why would I ever be sarcastic? So, guys, according to the model from that sheet last week, all right, what do we know about groups 1 and 2? All right, if you take a look at model number 1, what do we know about them?
They have a big atomic radius.
And nothing to do with atomic radius last week?
Am I wrong, but am I wrong?
Depends on which one you're talking about. Yep, but that's not what we're talking about. Guys, look back at the sheet from last week. What did you say, Shane? They have one ion, so they have one charge, guys, meaning we know their charges, all right, all the time. There's another group of elements where we know their charges. What would be one of those that has a single ion that forms? Again, this is where, looking at your worksheet from last week, the model on there, guys, is where you will find it. What's another element that has a single charge? Yes. It's similar to groups 1 and 2. So aluminum is one. Silver is another one. Zinc is the third one. So, guys, we can see that a mini staircase kind of starts to form here where we still know their charges. We're going to add 2 more elements. We're going to add gallium. And we're going to add cadmium to it as well. All of these elements that are in yellow are our type 1 elements. Type 1. What this means is that we know their charges. Our type 2 are all in blue. All right, so all the ones in blue, those are going to be type 2. What do you guys notice about type 2 elements? What are they mostly? What kind? Yeah, these are our transition metals. Guys, that term transition means what? They what?
Change.
They change, guys. So their charges will vary. Their charges will change. How do you think we're going to be able to identify what their charges are? When they're in a compound, how do you think we're going to be able to find out or identify what their charges are?
Comparing them to the other element?
Yeah, it depends on what the other element is, guys. We will always know. With ionic compounds, we will always know one charge of at least one of the elements in a compound. The other one we may know, we may not know. If we don't know it, it means it's a transition metal. So the charge will change. It depends on what it is bonded to. Then we'll be able to figure out the charge of the transition metal. And then our last type is going to be, for me, it's going to be an orange. Guys, the orange are type 3. What do you notice about all of these type 3 ones? What are they? Yeah, guys, these are our nonmetals. Shh. Type 3, nonmetals. We're going to know their charges as well, though. So with ionic compounds, we know, like I said, we'll always know at least one of the charges because we're always going to know the nonmetal charge. Okay? We may know the metal charge if it's a type 1. If it's a type 2, we will use our nonmetals and the charges that we do know of theirs to then calculate what the charge of the transition metal is. We will be doing this and learning this on Thursday of this week, guys. We will learn how to calculate charges with the transition metals on Thursday. When we come back on Wednesday, we will then talk about compounds. Today we're talking about just ions individually. So if we know their charges, group 1, guys, is a what charge always?
Positive.
More specifically?
1.
+1. All right, so group 1 is always a +1. Group 2? +2. Now, going back, to your sheet from last week, those other ones that we know, guys, silver, zinc, cadmium, gallium, and aluminum, it's like a staircase. When you go up a staircase, you get higher. So if we start at silver, what's silver's charge? This is where the sheet from last week. It's a +1. Silver, guys, is always a +1 for our purposes in this class. So as we go up a staircase, if I go up a step, what's my next charge going to be of zinc?
+2.
Yeah, look at that. It's +2. Cadmium's the same. +2. And then go up another step. Aluminum is +3. Same with gallium. Folks, look at this. Oh, group 11. Oh, look, there's a +1. Group 12. Oh, look, +2. Group 15. Oh, look, +3. All right, tells you the names. Memorize 1 and know that if you go up a step, it's 1 higher. If you go down, it's 1 less. Okay? Now, our nonmetals, we know their charges. Do the noble gases form a charge?
No.
Why not?
Because
Right, because they don't what? They don't bond. So group 17, what charge does group 17 have?
negative.
Negative what? -1. This is a review from our last unit. Group 16? -2. Group 15? Group 14? Partly. Plus or -4. And then boron would be? +3. It is. Yep. All right, so this is a review. 2 compound types, guys. Ionic, metal and a nonmetal, transfer of electrons, no big deal. We know this. Molecules, though, that's a new term. What does molecules mean? Look at what makes up a molecule, guys. 2 nonmetals through covalent bonding. So what type of compound is this? It's a covalent compound. So that's a new term. All right, you'll hear it both ways throughout the rest of the school year. A molecule is just a covalent compound. You've got to know it. They are interchangeable. 2 nonmetals through covalent bonds, so they are being shared. So this is, again, completely review. So, now, when we talk about chemical formulas, going off of those 2 last names that we had, ionic bonds and covalent or molecular compounds, all right, now we're talking about the formula. So molecular formula, what is that referring to?
Formula unit.
Nope. Molecular formula refers to a what?
Covalent bond.
Yeah, there it is, guys. It's a covalent compound. Covalent compound. So a formula unit, what do you think is?
Ionic compound.
It's an ionic compound. So these 2 terms, you will see a lot, especially in our next unit on the mole.
The mole?
The mole, not the animal that's in the, furry woodland creature, or that thing you might have on your back. It's a different mole. All right? Hey, it is what it is,
Yeah, I know.
Law of multiple proportions, guys. A proportion is basically a what? A ratio. So, guys, law of multiple proportions is basically, in its bare bones definition, all right, where you can have multiple ratios of different elements within a compound. So it's saying formulas can be different as long as they're in ratios. Okay, they have a set ratio, but they can have multiple different ones of the elements. And then polyatomic ion, molecular ion. What does it mean? What type of bonding is taking place with molecular ions? Or in polyatomic ions? That key term, molecular. It's covalent. All right? So it's a covalent compound that we have in our polyatomic ions. And it's charged. So guys, these next things, we're going to talk today about monatomic ions, but before you write anything in your notes, what I want you guys to write down is ionic naming rules. These ones we're talking about today and Wednesday are for ionic bonds only. So these are ionic naming rules. So make a heading in your notebook. Ionic, if I could spell it correctly. Oh no.
IONIC.
Close.
Rules are like musical rules,
These are the rules, the guidelines to follow.
but it's not like it's awesome like rules.
Oh no, it rules. I mean, it's awesome for sure. I mean, that's a given. It's chemistry, right? So, guys, we're starting with monatomic. What does monatomic mean? One atom in the ion. Okay, not polyatomic. We'll get to those on Wednesday. You already have a list of polyatomics you need to know for Thursday. We'll review those later in class today. So, alkaline earth metals plus our mini staircase. So this first rule here goes for basically the alkaline earth metals and our mini staircase. What type are these from what we drew earlier?
Metals.
That wasn't one of the types we had. Type 1. There it is. So guys, this rule corresponds to type 1. All right, it corresponds to type 1.
So it's not like the full staircase, just a type 1 staircase.
So our rule here for these elements, folks, is we take the name of the metal and we put ion after it. Everything we're dealing with today is not in a compound. These are ions by themselves. So we take the name of the metal and we put ion after it. That's how we name these type 1 ions. So here's our example. First one is Li. What is Li?
Lithium.
Lithium. So we're going to name it
Lithium ion.
lithium ion. That's it. That's it.
That's a little bit easier.
You guys go ahead and do the next 3. So, Na, guys, what would this be named?
Sodium ion.
Sodium ion.
Magnesium ion.
Then the magnesium ion will be the next one.
Calcium ion. Calcium.
Do you think you're going to have just a quiz of this?
No.
No. Now, it may be part of your quiz next week when you have mixed naming. But folks, we're starting off slow. Baby steps. Learning single ion names. We will put them together, like I said, on Wednesday. You do not want to miss Wednesday. There'll be a lot of information. We'll be recording it to upload that as well. If you are absent, you can go back and watch it. Alright, so that's it, guys, for type 1. We're going to move on to the next type of ion here. These are our transition metals. What did we already say about our transition metals? Wait, hold on. Go back here.
Change.
Before we do that, guys, last thing to add to this slide. Alright, we know their charges. Type 1, we know their charges. It's not a mystery to us. We know what their charges are. So we go on to the next one. Transition metals. Okay. Do we know their charges? No, they are unknown. The charges vary here. These are our type 2 from our periodic table that we colored earlier in the lesson. Okay. Type 2. For our type 2, we have to indicate what the charge of our ion is because they transition. They can change based on what they're bonded to. So this is where we use what's called the stock system. Alright, where the Roman numeral, that's not a good color.
Black.
It is.
Every color is a good color. What's that? Is that aquamarine?
I don't know. Guys, the Roman numeral indicates our charge. So we have to identify what the charge is. We're going to list the Roman numerals. You guys notice, guys, Roman numerals indicate the charge. We're going to list out 1 through 10 here. So, guys, we have our Roman numerals there. We will use those throughout the year at different times. Now let's go ahead and name them. So, we have a transition metal. We have to put the charge with it. Otherwise, we don't know what it could be because you could have multiple charges. So here, with ions, it's pretty easy. When we get into compounds and we have to calculate what the charge is, that's when things get kind of interesting. Thursday in class, we will be doing that. We'll be learning out how to figure out and calculate the charge on transition metals based on what it's bonded to. So here, Pb is what element? Lead. So how would we write this? This would be the lead. What goes in the parentheses? Yeah, Roman numeral 2. So this is lead 2, and like Jake said, ion. It's the lead 2 ion.
Wait, what's
All right, Pb3 plus, what would that be?
lead 3 ion?
Exactly. Folks, when we go from an ion to a name, it's not bad. It's, again, like I said, when we have a formula, a whole chemical formula with it bonded to something, that's when it gets challenging. So this is a lead 3 ion. Now the other way, we can go from the name back to the formula. That's a piece of cake because the Roman numeral tells us what right away? It tells you the charge, the number that you need to know, so you don't have, it takes the guesswork out of it. You don't have to figure anything out. It tells you right away. So iron, what's our symbol for iron? Fe, and it'd be the Fe3+. Iron 2 would be Fe2+. Guys, notice types 1 and types 2 are all what? They are all positive, guys. They are all positive. So add this to your notes. Type 1 and type 2 are all positive. Hydrogen would be the only exception. It can be positive or negative. All right, depending on what it's bonded to. What ion are we missing? The negative, which are called anions. So what do you think type 3 are? Anions. Guys, our nonmetals, type 3. Anions were the ones we were missing. They are type 3. This is the one where we change the most. All right, we drop our ending and we add IDE. So all ionic compounds end in "ide." Whether they are by themselves, like as a single ion, or they are in a compound, they all end with IDE because they're always going to end with an anion. The anion always comes second. So folks, our charges are known here. All right, we will know their charges. Again, going back to our colored in periodic table from earlier. Ide implies you have a what?
Anion.
An anion, guys. So ide, it does matter. So when you, on your quiz, put fluoride instead of fluorine, you change the chemistry up completely. Fluoride is good for you. You need it for your teeth. It's stable, right? It's an anion. You gain that extra electron, it's okay. Fluorine, though, can kill you if you have fluorine gas. It's not good. So fluorine, right here, when we change it to make it fluoride, we change the ending to IDE. Fluoride.
Where's fluorine found?
The top right.
No, not
In nature? I have to look it up. I don't know where it's naturally found. Not right now. I'll look it up later. Next one, guys. I. What element is that? Iodine. So when it becomes an ion, what do we call it? Iodide. Absolutely. You guys do the last two. All right, here we go. Oxygen becomes oxide. Nitrogen becomes nitride. So typically, folks, when you're doing a name, they will typically, not always, but most of the time, have 2 syllables. So if you have something like oxygenide or something like that, that's just kind of weird sounding. 2 syllables, folks, is really what you're kind of going for. All right, so those are our 3 rules, folks. Those are the 3 types. When they are by themselves as monatomic ions, type 1, 2, and 3, these are the rules that we follow.